Hello and welcome to another Ben Code Swift programming tutorial here in the Ben Code Swift programming series. Today we're going to be talking core motion. So, what I'm going to be asking you to do is sort of replicate this section of the class and this section of the storyboard, which is actually the only section, on your own. That way we don't have to take up video time while you watch. And we type the same thing over and over. So if you would file a new project, create a project called core motion or whatever you want to call it, and open up your main.storyboard file and your vcontroller.swift file. And start with these, just type in these variables here, and these are all separate labels, by the way, so you can see that there, and this is a button at the bottom. So the 0 obviously is a different label than the max rotation. So just start by putting those in, and I'm going to give a few seconds of silence here to pause the video, and then we'll jump right into it. Okay, so today we're going to be going over the gyroscope and the accelerometer, which are the two motion detection devices that iOS devices have built in. Which you can see what you typed in. The acceleration is the accelerometer, and the rotation is the gyroscope. And so what I'm going to ask you to do now is connect up all your outlets. And you're going to do that by looking at acceleration X and connect that right there. Same as the acceleration Y, acceleration Z, max acceleration X, and so on. So just connect those up and connect them to the numbers, or by the way, remember, not the text labels. Okay, and the way this is going to work is I already have the code built out because I don't want to waste a lot of time typing out the code, so I'm going to give you guys a couple seconds before we talk about each part of the code to get that down, and then we're going to go and explain it piece by piece. Right, so the first thing I'm going to explain is what this is. So each time you want to use the accelerometer and the gyroscope in your app, you need to use what's called a CM Motion Manager. Okay, and a CM Motion Manager is it basically is how you're going to access the various devices built in for motion, for core motion, all that stuff. So everything you use with core motion, you're going to use a core motion manager. Notice we put import core motion at the top. Okay, that's necessary because you need the core motion framework in order to be able to put in a CM motion manager. You can't do that without the framework. Now the first thing you do before anything is you're going to need to go to core motion, to your project file, and look under, when you're on the target selected general, look under linked frameworks and library. This won't be there for you. Just hit the plus sign and scroll down to core motion and hit add. And it will be there. You'll see it on your left if you've done it correctly. Okay, so we've created our motion manager, and that's how we're going to access all the services. We've created a bunch of values where we can store the, we're going to be able to store the most acceleration we've had so far on all three axes and the most rotation we've had so far on all three axes in these double instance variables. So those are for. We don't really need to store the current values because they're going to be updating so quickly. So the first thing we're going to do is we're just going to create an IB action for reset maximum values, and we're just going to set all of our 6 instance variables to 0. Pretty simple. So I'll give you a couple seconds to just get that down. When you've completed that, we're going to start with a viewDidLoad, fairly lengthy viewDidLoad method. Let me just drag this over a little bit. Look better. Perfect. Okay. So the first thing we're going to do in viewDidLoad is just make sure that we're all at 0. So we're just going to take our 6 again and set to 0s. If you want, you can just do a call to reset max values. That's fine too. In fact, I'm just going to do that now. I'll just go. Yeah, that works too. Just reset those all. And then what you're going to do is you're first going to set you're going to set your properties. You're going to set the motion manager properties, right? And what that means is, you just need to sort of get it ready before you launch right into it. And so the first thing you're going to set is your accelerometer update interval, or in other words, how often you check for your new acceleration, and that is seconds. Okay, so set that to 0.2, and the same thing with your gyro update interval, which is your gyroscope. As you can see, it's in seconds, so this is every 0.2 of a second. When you've done that, now we need to start actually, now that we've set up our motion manager as we want it, we now need to start recording data. So this is done by a function called start accelerometer updates to Q. And that's part of your motion manager, so you're going to call that through motion manager. And so, as you can tell, it's a handler and a NS operation queue. So if we click, we can watch here. So as you can see, if we go to Swift, what we got for the handler is it's actually a I'm sort of assuming here that you've talked about this before. But we're basically putting in a function as a variable, okay? Is sort of what we're doing here. As you can see, what it's asking for when you pass in the CM accelerometer handlers, it's actually asking for a function that takes in accelerometer data and an error and returns void. And so we're doing that here, okay? And these are called closures. They exist in other languages, so if you've studied other languages, you've probably seen them. But it's a closure here, right? So for our first, what we're passing in for the NS operation queue, we're passing NS operation queue.current queue. That's just going to say whatever block or whatever queue calls this method, we're going to run on the same one. So that's all it needs. It's not important for this time because we're not going to be over, it's not going to be too much for the device to handle. And then our second parameter is going to be with handler, and we're going to pass in this whole closure. And this is the, we're not really going to talk about it now, the format for creating closures, but basically, as you would in a normal function, this is your parameters with your return type of void. And in takes the place of the opening. Or in sort of starts your closure code. So in the method, in the function, you have self.output acceleration data, accelerometer data.acceleration. This doesn't exist yet for you, so don't worry about that. We're going to create that later on. And what you're going to pass in is you're going to pass in your accelerometer data from above dot acceleration. Okay, and then just check for your error, and if it is, print it. Same thing with gyro. Just change everything to gyro and set it for the gyro. So I'll give you guys a few seconds to do that. But this is going to start recording the updates, and when we say output acceleration data, in other words, this is going to start recording it, and it tells it to send all of the data to this function. So I'll give you guys 4 seconds to pause the video, and then we'll move on. Alright, so once you have that, now we've got our motion manager built, and it's recording our data, and it knows where to send it to. But now we need to sort of accept the data and parse it in a way that we can use. So we're going to create a function called output acceleration data, acceleration CM acceleration, okay? And what we're going to do first is we're going to take our acceleration data and we're going to grab the specific x value of all the acceleration. So acceleration holds everything. But we just want the x value because we're showing them individually. So we're going to set the text of our x acceleration label, acceleration x.text, 2, and keep in mind we're using the escape character here so we can pass in a variable right here, and then this is the label right there. Okay. And do the same thing for Y and Z. Okay. And then this, if you notice, fabs is the absolute value function of a floating point number. That's what fabs means. It's just a math method in Swift. So in other words, we're getting the, we want the biggest max acceleration. So even if it's like negative, but it's big, that's what we want. So that's why we're using the absolute value. And so this is just to check if the current is bigger. If the current is bigger than, if the current one is bigger than the maximum, then we're going to set the maximum to the current one, obviously. And we're doing that for each one. And then at the end, we're just going to update our maximums. And keep in mind, this is legal. We don't need to check for these ones because it's not going to update, so it'll show the same thing through those if it didn't get bigger. So I'll give you guys a few seconds to get that down. And then we're going to do the same thing for output rotation data. So I'm going to give you guys a few seconds now to actually just type this through because it's pretty much the same thing. Alright, once you have that down, this is the app. And what it's going to do is it's going to show us as we move our device how these things work. And you're going to need an actual device, unfortunately. You can't test this in the simulator. It only works on an actual device. Okay, but basically what you're looking at is these are the... by the way, this tutorial is sort of modified for Minutes Cookbook, so thank them for the original tutorial. But you won't find this with Swift or anything like that on there. But I did love this picture. And this basically shows the accelerometer axes. For instance, you can see Z. So imagine your phone or your iPhone or your iPad is lying straight, flat on a desk. If you lift it up with your screen still sort of at a 90-degree angle, it's still flat, but it's just lifted up off the desk, that's Z rotation, or that's Z movement. If you slide it left or right, that's X movement, and if you slide it front or back with the screen still facing up, the key is in all of these, the screen is still facing up, those are X and Y movement. With the gyroscope, it's sort of harder to think about. If you think your screen is flat and you rotate your device left, so your screen is now at a 90-degree angle, or you rotate it right, that's your Y. If you think of your screen facing you, so the top of your phone is facing towards the ceiling or the sky, and your screen is facing towards you, and you move it you rotate it to the left or the right, that's your Z, and if front or back in any rotation is your X. Okay, so it's sort of hard to consider, and you can always look it up again, but that's sort of how you use your gyroscope and your accelerometer. So now what I'm going to do is I'm going to actually run the CoreMotion app, and I'm going to just show you guys on screen, and I'll tell you how the movements are just so that you can follow along. So you can see just exactly how precise the accelerometer and gyroscopes are because of how precise the values are. But yeah, and you can see the max is only updated when it's bigger. So what I'm going to do now is I'm going to place my phone flat on my desk and reset. First thing I'm going to do is I'm going to lift my phone up with it still flat. And let me do that again. And as you can see, it's my Z acceleration, really. That's getting the big value here. Let me do that once more. So, my Z acceleration again. Okay, I'm going to move my phone left to right. And that, as you can see, is my X. And I'll move it front and back for my Y. And as you can see, my Y goes up. Okay. Now I'll hold my phone straight up, and I'll sort of rotate it front and back, and there's my X. Now I'll hold my phone with my screen facing me, and I'll rotate left and right for my Z. So you see my Z shoots up, and now I'll hold my phone flat, and I'll rotate it left and right like this, and there's my Y. Okay. So that, that is your CoreMotion. You can install it on a device and, use all of these things, but I hope this was helpful. check back soon for the next video, and I appreciate you watching. And next time we'll cover some more cool stuff. So this is how you use your accelerometer gyroscope for core motion. Thanks.